are you doing? Thank you for watching another video of Mr. Woodford. Today we're going to be looking at lesson 1.7 for our Math 8 class. Once again, if you are at home, if you have the packet in front of you, please open up to lesson 1.7. If you're joining us and you're looking at, you want to look at the lesson, you can always click on a link, or you could look on your Google Classroom page to the actual assignment as well. So let me share my screen. As we usually do, we start off every lesson by looking at a bell work assignment, which is our first 5 minutes of our class. For now, what I want you to do is I want you to identify what the square roots of these perfect squares are. If you notice, the first and the fifth are done for you. A, which says the square root of 1 is 1. And then E, which tells you the square root of 25 is 5. And if you remember, we went over the perfect squares in the last lesson. Can you tell me what the square root of those perfect squares are? So I'm gonna give you a minute, pause the video if you need to actually tell me what those are. All right, so I'm hoping that you had a chance to pause the video. I'm gonna quickly go over them. And once again, if you have any questions, always feel free to write your questions in the Google Classroom page or underneath this video. So if I look at B, and I identify the second perfect square. So if the first one is 1, the second perfect square is going to be 4. So what is the square root of 4? I'm hoping that you know the square root of 4 is 2. The third perfect square we've discussed is 9. What is the square root of 9? 3. And I'm pretty sure by now you're catching on to how this is working. So the square root of 16, you guessed it, it's 4. I already did the square root of 25 is 5. So let's go on to the next one. The square root of 36 is 6. And once again, what makes a number a perfect square is this number that we're looking at, 2, or in this case. So you see how this is the square root of 4. 4 is a perfect square. Now how do we get 4 as a perfect square? Because that's made up of 2 times 2. 9 is a perfect square. How do we get 9? 9 is made up of 3 times 3. Notice it's the same number multiplied by itself. So we're taking the square root of those perfect squares, and notice how it's going backwards. Notice how it's honestly rewinding us back to where we was originally. So the square root of 49 is 7 times 7, so that means it has to be 7. Square root of 64, which is 8 times 8, which means the square root of 64 has to be 8. Square root of 81. 81 is 9 times 9, which means the square root of 81 is just 9. And finally, the square root of 100, which 100 is 10 times 10, which means the square root has to be 10. All right, so I'm hoping that you are getting a better understanding of square roots and even a better understanding of perfect squares. Now, as we talked about in the last lesson, we talked about rational and irrational numbers. We talked about what makes something irrational, what makes something rational, right? We looked at other radicals, and we discussed whether or not any number that is a radical is rational or irrational. And we've identified, obviously, all these perfect squares. But we've also talked about if a number can be written as a ratio or as a fraction, that is how we determine it is rational. Now, today's lesson, we're not going to classify if they're rational or irrational. Today, I'm going to give you irrational numbers, and I want to see if you can place those numbers on the number line, because we still need to remember that rational and irrational numbers all fit underneath this big bubble called real numbers. So they're on the number line somewhere, but where? Where are they? So we're going to look at them and see where they are on the number line. And we're going to identify them by drawing little dots, drawing arrows if we wanted to really understand exactly where they are. So before we do that, once again, just to give you a chance to remember these perfect squares, what is the square root of 100? What is the square root of 81? What is the square root of 49? And what is the square root of 64? If you said 10, 9, 7, and 8, you're absolutely right. And now you can remember, this is kind of what we went over in the beginning just now, but I really want you to know something. Now, see these numbers. Why am I going over these perfect square roots? Why are we going over this? Because this is going to help us to really find where other square roots fit on the number line. For example, let me model for you, and I'm going to show you 6 square roots, and I'm going to point out where they belong on the number line. And after I point out where they belong on the number line, I want you to pay attention to how I found that out. Notice, we could turn all these into decimals. We could. But that's not the technique I want to use today. Instead, I want you to use some deductive reasoning to say, okay, if I know that this number, square root of, let's say, 4, is 2, then the square root of 4, maybe if I gave you the square root of 5, you would know that's a little bit bigger than the square root of 4. So that would mean it has to be a little bit bigger than 2, right? So let me show you a couple examples. So for example, let's say we looked at this first one. It says the square root of 15. And that's how we read this, just so we're all on the same page. The square root of 15, all right? As I mentioned in the lesson before, some people say radical 15. You could say radical 15, or you could say the square root of 15. We're going to say the square root of 15 here. Now, the square root of 15 is between 2 perfect squares. All of these numbers are between 2 perfect squares. Now, where are they at? Where are they between? The square root of 15, and you can always use the bell work that we created at the top to help you look here, right? Square root of 15 is between the square root of 9 and the square root of 16. Now, just a refresher, the square root of 9 is equal to what? 3. Right? And we mentioned that above. If you scroll up, you'll see the square root of 9 is equal to 3. The square root of 16, what is that equal to? That's equal to 4. So even though if you see 15 is between 9 and 16, these are both perfect squares. I know square root of 15 is probably not. It's irrational, right? So I'm saying, okay, where does this belong on the number line? Since I know the square root of 9 is 3, and I know the square root of 16 is 4, that means the square root of 15 is somewhere between those two. So I'm going to go on my number line, and I'm going to create a nice little dot right here. Say right there. And I'm going to draw me an arrow. And I'm just going to write the square root of 15 here. Okay? That's indicating that the square root of 15 is between 3 and 4. Let's do another one. Right? I'm going to do all 5 of these with you. And then I want you to go and do the reflection. I want you to work on independent practice. And feel free to ask any questions along the way in Google Classroom or underneath this video. Negative radical 80, or negative square root of 80. Now notice that negative is on the outside, right? That negative is on the outside, which means that this is going to be a negative number. It's going to be a negative number. Now, 80, the square root of 80, where does the square root of 80 fit? I know it has to be between the square root, and we're looking at perfect squares. Think about perfect squares for a second. It's got to be between the square root of negative square root of 64 and between the square root of negative 81. It's got to be between the negative square root of 64 and the negative square root of 81. So it's between those two numbers, right? That's not a plus symbol in the middle. That's just saying that's between those two numbers. So what is the square root of negative 64? This is really negative 8. This is really negative 9. So that means the square root of negative, the negative square root of 80 has to be between negative 8 and negative 9. So I'm going to go on my number line. I'm going to create me a nice little circle. Now, is it closer to negative 8 or is it closer to negative 9? Well, how am I supposed to know that, Mr. Warford? If you see, negative 9 is really the square root of 81. So if we're looking for the square root of 80, that would mean it's closer to negative 9 than it is to negative 8. So I'm just going to draw a dot here closer to negative 9 with a little arrow pointing up, and I'm going to label that negative square root of 80. Okay. At this point, you should be getting a little bit more familiar with, oh, okay, I see what we're doing. We recognize what numbers this one is between, right? Which perfect squares is between. So look, if we look at 21, right, the square root of 21, we can think, okay, well, I know that there's a perfect square of the square root of 16. I know the perfect square of 25, right? So it's got to be between the square root of 16 and the square root of 25. It's got to be between there because the square root of 21 is in the middle of those two numbers, right? But then you have to ask yourself, okay, well, square root of 16. Square root of 16, and let me just change the color. Square root of 16, what is that really? And what square root of 25, what is that? So square root of 16, we know that's 4. Square root of 25, we should know that is 5, right? So we're really saying that the square root of 21 is between 4 and 5. And once again, we can say, okay, which one is it closer to? Now this one is a little bit closer to the middle, but nonetheless, we can see that it's closer to the square root of 25, okay? So I'm gonna go to 5, positive 5, not negative 5, right? Because there's no negative in front of that one. And I'm gonna draw me a dot like right here. Looks like it's in the middle. It's actually leaning a little bit more towards the 5. I'm gonna write the square root of 21. And I'm gonna go through each one of these and do the same thing. So the square root of negative square root of 44, I know that's between square root of negative square root of 36 and negative square root of 49, which means negative square root of 36, I'll do this in blue as well, and negative square root of 49, that's really like saying it's between negative 6 and between negative 7. And we can say, okay, which one is it closer to? We can see that it's a little bit closer to negative 30, square root of 36. Mr. How can you see that? How can you see that? Well, you're actually right. Let me actually look at it again. Let's figure this out. 36 to 44. That is really only 8 digits away. 8. 44 to 49, that's only 5 digits away. So actually, I stand corrected. It's closer to negative 7 than it is to negative 6. So I'm going to go to my negative 7, and I'm going to draw me a dot right here. And once again, you got it. I'm going to label this negative square root 44. Negative square root 44. Okay. So now I have all these numbers and where they belong, and of course I have 2 more. Right, and I'm just going to go quickly. And if you got the concept here, you can fast forward it through. You can begin to end the video and begin to work on your portion of your worksheet. But I'm going to go through square root of 98. Quickly, you should know that that's closer to the square root of 100, right? And square root of 100 is 10. And then the square root of 11, which is closer to the square root of 16 than it is to the square root of 9. Nope, it's close to the square root of 9. I apologize. So it's close to the square root of 9. I'm just thinking on top of my head quickly, right? So this is close to the square root of 9. We're going to put it a little bit below, a little bit above, right? 3, but a little bit below radical 15. So let's actually put the dot right here. Let's draw the arrow right here, and let's label that square root of 11. We'll get rid of that other dot there. Okay. And this is good because it's important that when you put them, if you got multiple radicals that you have to put down, you don't want them overlapping each other. So I could have spaced out the radical 15 a little bit more to make space for the square root of 11. But this is how I would put all 6 of these numbers on the number line, okay? Without turning them into decimals, we're just literally looking at comparing them to the perfect squares, and that's how we can put them on the number line, okay? Take a second to read through this reflection question and analyze and say, okay, well, what symbol would I put in the middle here? Would I say that square root of 11 is smaller? Would I say it's bigger? Would I say it's the same as the square root of 21, okay? So I'm hoping that this lesson helped you. I'm hoping that you got a little bit of clarification from it. Remember, you can always rewind the lesson or restart it to get a better understanding of it. But until next time, thank you so much for joining me. Have a wonderful day. Bye-bye.